Hello world, it's TNU Engineer. Today in our new video we are going to learn how to model a landslide, okay, using the software Abaqus. Okay, so what to do next? We'll first of all start by creating a part has all the model that you are going to model using Abaqus. You always start by creating a new part. Okay, so you make sure that you are on the module part. As you can see, you click on create a new part. You can give it a name, for example slope for me, since it's a landslide. Okay, enter. I've given the name of my part. Now I will create a line, then I'll enter the coordinate 0, 0. Then this point will appear. I'll enter now 6.67, 0, enter, then escape, then create line again. Come and click here, click 0, then 0, 10, press enter. As you can see, I will zoom out. This is my slope that I have chosen. That's why I entered those dimensions, because I wanted to have a slope of at least 56 degrees. That's my choice. It depends on you. The remaining I just draw it arbitrarily. Okay, then escape, then I will erase. I click here on auto trim, and then I trim what I don't need. That's it. I've created my part. So I'll come here, click on cancel, then on done. I will choose the depth, since it's a 3D model and deformable model as you saw there. So I'll click 5. That's my model that's appear. You can create a 2D model. Remember, when you click on create part, you will see 2D or 3D. So that's it. My model, my 3D model is created. My part is created. So what I do next is the property of my soil. Okay, since I'm modeling a landslide. Okay, so I'll click on create material. I will name it soil material. Okay, let me click here, soil material. Okay, then okay, I will come specify the density. I will choose 1700. Okay, 1700 or 1700 for the density. I will choose elasticity. The elasticity, let me say I will take 30 million of Pascal. It's in Pascal. Okay, so 30, that's 1 2 3 1 2 3 1. Okay, that's 30 million. Then I have my Poisson ratio. I will choose 0.45. Okay, it's a choice. Depending on the parameter of your soil, you will know what to choose best. Then I will take plasticity, the more Coulomb plasticity. Okay, for the type of ground that I'm using. That's the type of elasticity of my ground. The friction angle I will specify, for example, 23 degrees. Okay, for the dilatation angle, since I don't have it, I will just enter, for example, a random value 1 degree. Okay, so I've created the property of my material. As you can see, I click on OK. Tabular data for at least one option or sub-option, either blank or 0 value. This means okay. Let me check cohesion. Okay, I did not enter my cohesion. That's my yield stress. Okay, so I will enter here 30,000, for example. All these values are in Pascal. Okay, it's a conversion in Pascal. That's how Abaqus function normally. It doesn't work with the multiple, but it simply works with either meter, pascal instead of megapascal or kilopascal. For the strain, the strain, I will just take 0 for no deformation. Okay, now I can click on OK. So my material property has been created. What I do next is to create a section. Homogeneous. Here I want the material to be apparent on all this thing under a solid. As you can see there, I can name it, but I'll just leave it hand only that name section 1. I click on continue. You can see my soil material here. I click on OK. Then now what I do next is that I assign that section that I just created. When I click on assign section here, as you can see, I come here, I select my part, then I click on done down here. Okay, when you create on done, they will show you the section 1 that you just created or above. Okay, the soil material, the type. Okay, so you just create on okay. So that's it. I've assigned my property to my material. Then on assembly, I'll create the assembly, click on create instance. Then I will ensure that I choose independent for the machine. Okay, so when I choose my independent, no much to parameter again, I'll just click on okay. So I'm done with my assembly. Then I go under steps. I will create a step now. Okay, step. I'll leave the name there randomly. Okay, now for down here, the procedure type, I will choose since it's a ground displacement with a small cohesion, I will come and choose dynamic explicit. Okay, dynamic explicit for ground with a low cohesion. Okay, so I click there on okay. My time period, I will just choose 10. Okay, and then I will leave this parameter activated like this. Everything here automatically be okay. I will not have to parameter much, so I just click on okay. So for interaction, I will not create no interaction inside my particle, so I go directly to load. Okay, for the load now, I'll create the boundary condition. Okay, so under boundary condition, I will start by set my base to be fixed, the base of my landslide. Okay, so I click on continue. You can see symmetry or encaster. So I will click on the base, select it, click on done, then choose encaster. As you can see here, u1, u2, u3, everything is equal to 0. It has been applied. Then now the lateral side of my drawing. Okay, so that's it. I click there, I select them, I click on create boundary condition. Now I choose displacement and rotation, no more fixed. Okay, so I click on continue. Now I will click on done because I have selected the lateral side already. Now I don't want my ground to be moving. I don't want any displacement along the u3 component, that's the z component. Okay, that's why I tick here, and then I create okay. As you can see, I've applied the boundary condition. Then we'll create another boundary condition, which is around this face. Okay, the faces that are opposite to the slope face. Okay, then that's it. I've selected. Now what I will do is that I will maintain control, then click here. Okay, no, I click first of all, then I click maintain shift and click. I'm trying to create another boundary, the last boundary condition. I'm still under rotation. Okay, so when I'm done, I'm trying to click here, control, or click here. I've selected this face. It's a bit disturbing. No, I'm not yet there. Let me start back. Create boundary condition, continue. Then I select this, maintain control, press. I select these two lines. Okay, these edges, as you can see, the color tend to be pink. Okay, make sure you do the same. Then now I click here, I see maintain shift, I click here on this face, and then control to click on these edges, as you can see. Then I'll create my boundary condition. I'll click on done now. Under done now, I don't want any displacement around the u1, that's horizontal displacement. Okay, so I'll cancel the displacement here. I will set it to be fixed, as you can see, 0. Then it's okay for my boundary condition. Okay, so that's it. I will not apply no pour water pressure in this example or anything. I will now create the load. We'll use the gravity load. Okay, so we'll search for gravity. This gravity, I'll just click on continue. Then I'll still specify the magnitude 9.81. okay, meter per second square. Okay, that's the magnitude. Negative, since the gravity is looking downward. Okay, specified. So I click on okay. It has been applied. You can see this yellow arrow pointing down. That's the load that has been created. So when I'm done with load, what I do next is what? I mesh it. I'll create a mesh. So I'll just create a seed part instance. I click on it. Okay, I choose the size that suits me the best. I will just use, let's say, 1.5. okay, the size of my machine. I apply it. You can see. Okay, I will know. For you, you can decide for more accuracy to make it more smaller, even 1 meter or even 0.5 depending. Okay, then I create on mesh, as you can see, mesh part instant. Then I click on yes here. That is it, the meshing is done. After that, the meshing is done. Now I'll go under job. I'll create my job. Okay, I just click here, create a job. Job 1, I will leave the name that they have given to it. No parameter. If your computer is powerful, you can activate some of these tools depending on what you are expecting. Okay, you will just read them. Okay, so I've created my job. I scroll down here to see job. This is my job. I click here on job 1. I click for data check first of all to ensure that there is no error, and then they will process it and tell me if there are errors. Okay, the check is completed, so no error. So now what I do next is to submit my job for analysis. I click on submit. After I click on the job, I click on submit. Okay, so that's it successfully. As you can see down here, this is it. The analysis has been completed successfully. So now I right click again on the job, and then I go under result. Okay, to see how it looks like. Then that's it, I'm under result. I click on the deformation, plot contour deform. Click here to see how it behaves here. That's the stress repartition. This S misses. Okay, that's the stress. This is the zone with the highest stress for my structure. Okay, so now I can put U here for the displacement. As you can see, that's the displacement over here. Okay, this is the displacement, that's the magnitude. To see the maximum displacement, that's you go under magnitude here, or to see the displacement along U1 where we allow. Okay, you can turn, you will see this is the displacement. Okay, that's the displacement. This is the ground. The place in red show the maximum displacement. That's where our landslide tend to occur at the toe of our slope. Okay, this is a bit it. So you can press layer for small simulation. Shows the deflected shape. Okay, then you press again. The speed is too much. Okay, so that's it. I will know the video was just for you to see how to model landslide. For the other purpose, just ask in the section comment, and then I will guide you. I will make another video to teach you how to do it. Okay, thank you very much. It was NGU, and don't forget to subscribe to the channel and share the video all around with your friend. Okay, thank you very much. See you soon.